You think you know what cold is. You feel it every day. You open a window in January and you feel a draft. You say the cold is coming in. You drop an ice cube into your lemonade and you think that ice is adding cold to my drink. But here is the problem. Physics says you are fundamentally wrong. Cold does not exist. It is not a thing. It is not a substance. It is not a force. You cannot measure coldness because there is nothing there to measure. Cold is just a word we use to hide the truth. It is a ghost word. In this video, I'm going to show you that there is only heat and the lack of it. We are going to dismantle your understanding of temperature and replace it with the terrifying, beautiful concept of entropy. We are going to explore why you can never unmix your coffee, why time only moves forward, and why the universe is slowly, inevitably freezing to death. By the end of this, you won't just look at an open window differently. You will understand the fundamental engine that drives reality. Do this right now. Put your hand on the desk or table in front of you. Just hold it there. You feel the surface is cool, right? You think the desk is transmitting cold into your hand. Wrong. That sensation you are feeling is the heat energy of your body frantically escaping into the wood. You are bleeding energy. You aren't sensing the table. You are sensing the loss of yourself. To understand why this happens, we have to stop looking at objects as solid things and start looking at them as they really are. Collections of billions of atoms. What is heat? It's not a fluid. Ancient scientists thought it was a fluid called caloric that poured from hot things to cold things. They were wrong. Heat is motion. It is the jiggling of atoms. That's it. Imagine a crowded dance floor, a mosh pit. Everyone is jumping, dancing, bumping into each other, slamming shoulders. That is a hot object. The people are atoms, and the dancing is the heat. The more violent the dancing, the hotter the object. Now imagine a room next door that is empty and still, a library. If you open the large double doors between the mosh pit and the library, what happens? Do the quiet people from the library rush in and calm down the dancers? No, there are no people in the library. Quiet isn't a force. What happens is the dancers naturally spill out. They get bumped, pushed, and shoved until they stumble through the door into the empty room. They spread the chaos. The energy, the dances simply spreads out because there is more room to dance. This is exactly what happens with your open window. The cold air outside isn't rushing in to attack you. The heat energy in your living room, the jiggling nitrogen and oxygen atoms, is frantically banging against the window. When you open it, they escape to the outside to warm up the universe. You aren't feeling cold coming in, you are feeling the life energy of your house bleeding out. So here is the question that should bother you. If heat is just atoms bouncing around, why doesn't it ever go the other way? Why don't the atoms outside ever accidentally bounce into your house and warm it up? Why does the heat always leave? This brings us to the deepest law in the universe. It's called the second law of thermodynamics, but I prefer to call it the accident. We observe that things go from order to disorder. Always. If you drop a cup, it breaks. If you wait 100 years, the pieces don't jump back up and seal themselves. If you put a drop of blue ink into a glass of clear water, it spreads out until the water is light blue. It never gathers back into a drop. Why? Is there a law of physics that says atoms can't move backward? No. If you look at an individual collision between two atoms, it is perfectly reversible. If you record two molecules hitting each other and play the film backward, it looks perfectly natural. The laws of physics work exactly the same forward and backward. So if every single atomic collision is reversible, why is the whole picture irreversible? Why can't we unmix the ink? It comes down to statistics. It's a numbers game. Think of a deck of cards. There is only one way for the deck to be perfectly ordered, ace to king, suited perfectly. That is a state of high order, low entropy. But there are millions and billions of ways for the cards to be mixed up. When you shuffle the deck, you are moving from a state with one possibility to a state with billions of possibilities. It's not that the universe hates order. It's just that there are so many more ways to be messy than to be tidy. When the ink spreads in the water, the molecules are just jiggling randomly. They could accidentally all jiggle back into the corner to form a drop. It is not physically impossible. It doesn't violate the laws of motion. but it is so staggeringly unlikely that you would have to wait longer than the lifetime of the universe to see it happen once. The arrow of time, the fact that the past looks different from the future, is just an accident of probability. Things fall apart because there are more ways to be apart than together. Look around your room right now. Really look. Every single object you see, the chair, the computer, the coffee cup, is slowly disintegrating. The atoms are vibrating, rubbing, and slowly dispersing. The only reason it looks solid to you is that you aren't watching long enough. Now let's talk about why this matters to you. Why should you care about jiggling atoms? Because this flow of heat, this spread from high concentration to low concentration, is the only reason anything happens. It is the source of all useful energy. But there is a catch. Energy is only useful when it is uneven. Richard Feynman gave a brilliant analogy for this. Imagine you go to the beach with a stack of dry towels. You jump in the ocean, get wet, and grab a towel. The towel is dry, you are wet. Nature wants to equalize this. So the water moves from you to the towel, you get drier, the towel gets wetter. Now you grab a second towel, it works great, but imagine a sudden downpour of rain soaks the entire beach. All the towels are wet. You are wet. The sand is wet. Now try to dry yourself. You pick up a damp towel, you rub it on your damp skin. What happens? Nothing useful. You don't get drier. The water just swaps back and forth. The total amount of water hasn't changed. The energy is still there, but the availability of the energy is gone. This is what we call equilibrium. And in physics, equilibrium is death. We can only run an engine or a computer or a human body if there is a difference in temperature. We need a hot side and a cold side. We need the dancers to want to leave the room. If the whole universe reaches the same temperature, if the mosh pit and the library are both half full and equally loud, nothing can happen. No energy can flow, no work can be done. Wait, you might say. If heat is just random jiggling, can't we build a machine to trap it? This is a question that stumps engineering students. The air in this room is full of energy. The nitrogen molecules are banging against the walls at hundreds of miles an hour. Why can't we put a little wheel in the air, let the molecules hit it, and use that spinning wheel to charge our phones? Why do we need batteries if the air is hot? Let's imagine such a machine. It's called a Ratchet Pawl. You have a wheel with teeth. A little arm stops it from spinning backward. So when a molecule hits it this way, it turns. When a molecule hits it the other way, the pawl jams it. In theory, the wheel should only turn one way. We could harvest the random heat of the air and turn it into directed motion, perpetual energy. But here is the catch that destroys the dream. The machine itself is made of atoms. And if the machine is in the same room as the air, the machine gets hot. The little arm, the pawl, starts to jiggle. It vibrates. Because it's jiggling, sometimes it bounces up. And precisely when it bounces up, the wheel can slip backward. Feynman showed mathematically that if the gas and the machine are at the same temperature, the pawl will bounce up exactly often enough to cancel out any forward motion. The wheel will jiggle back and forth, but it will not spin. It will do zero work. You cannot win against entropy. You cannot extract energy from a system that is at equilibrium. You can't dry yourself with a wet towel. This isn't just about wheels. This is why perpetual motion scams are always fake. If someone tries to sell you a device that creates energy from magnets or vibration without a fuel source or a temperature difference, walk away. They are trying to sell you a wet towel, so heat is motion, and cooling is just slowing that motion down. Logic suggests that if we keep cooling something, eventually the motion should stop completely. The dancers should freeze in place. We call this theoretical limit absolute zero. 273.15 degrees Celsius. But here is where reality breaks your brain again. You can never actually reach absolute zero. Nature forbids it. Why? Because of quantum mechanics. If an atom stopped moving completely, we would know exactly where it was and exactly how fast it was moving. The Heisenberg uncertainty principle says you cannot know both of those things at once. Nature demands a certain amount of fuzziness. So even at the coldest possible temperature, atoms still shiver. They have a tiny residual vibration called zero-point energy. You cannot freeze the universe into total stillness. The dancers never truly sleep. They just sway in place forever. Let's zoom out. We've talked about heat, towels, and ratchets. But what does this actually mean for you? It explains why you can remember the past but not the future. Think about it. Why is the past fixed and the future distinct? The laws of gravity work the same backward. The laws of electricity work the same backward. The only thing that distinguishes the past from the future is entropy. The past is the time when things were more ordered. The future is the time when things will be more messy. How did we get ordered in the first place? This is the deepest mystery. For entropy to always increase, the universe must have started in a state of incredibly high order, low entropy. The Big Bang wasn't just an explosion of energy, it was an explosion of structure. Ever since that moment, the universe has been unwinding, like a clock that was wound up at the beginning of time and is slowly ticking down. Every time you light a match, you are releasing stored sunlight and turning it into heat. Every time you eat food, you are taking complex molecules and breaking them down into simple waste heat to keep your body alive. You are a machine that consumes order and excretes chaos. That is the definition of life. Pause and think about this. You struggle to keep your house clean, right? You clean it, and a week later, it's messy again. You think you're failing, you aren't. You're fighting the fundamental law of the universe. To organize your room, you have to expend energy. You can create a local pocket of order, a clean room, a baby, a skyscraper, but only by making the rest of the universe messier. The tax must always be paid. Where does this lead? If heat always spreads out, if the towels always get damp, if the dancers always leave the floor, then eventually everything will be evenly spread out. There will come a time when all the stars burn out. They are giant engines converting nuclear order into heat disorder. When they run out of fuel, they go dark. Black holes will evaporate. Matter will decay. The universe will reach a state where the temperature is exactly the same everywhere. No hot spots, no cold spots. Just a uniform, lukewarm soup of particles floating in the dark. No energy can flow. No thoughts can be thought. No clocks can tick. Time itself, in a physical sense, will stop. This is called the heat death of the universe. It is the ultimate equilibrium, the ultimate wet towel. This sounds depressing, I know. But Feynman taught us to find beauty in the truth, no matter how strange it is. Knowing that cold is a lie and that entropy is the ruler of time gives you a superpower. It gives you a lens to understand why things happen. So I've created a simple mental tool for you. The entropy lens. 1. Energy flows downhill. If something happens spontaneously, it's because energy is spreading out. 2. Order requires cost. If you see structure, ask, what paid the entropy tax for this? 3. Equilibrium is death. Seek difference. Seek contrast. That is where life lives. Next time you feel a draft from a window, don't shiver and complain about the cold. Remember that you are feeling the grand, tragic, beautiful march of the universe toward its destiny. You are feeling the dancer's escape. If you want to understand more about the heat death and the physics that governs the end of reality, hit subscribe. We are going to dive deep into black holes next. And if you want to master these concepts without the jargon, I've put together a Thermodynamics for non-physicists concept map. It's a visual guide to everything we talked about today, entropy, enthalpy, and the arrow of time. You can join the waitlist to get it for free at the link in the description. Stop believing in cold. Start believing in the jiggle.